Hi children, today we are starting our new chapter, that is gravitation. What is it? Gravitation. Okay. What do you mean by gravitation? I think in the 8th standard you have studied the force of gravitation. What is gravitation? Yes, you know every object in the universe attracts with each other. Are you heard about the great scientist Isaac Newton? In the last chapter we studied Newton's laws of motion. In this class we study about gravitation. This gravitation is discovered by the great scientist Newton. Okay, do you heard a story about Newton? Once upon a time, Newton sitting under the apple tree, then suddenly apple falls on his head. At that time he thinks that why do the apple falls always in the downward? Why didn't the apple move upward? Yes, you know, this is a chalk. When I put this chalk falls downward. Why? Because the earth attracts every object on the earth towards its center. Suppose this is our earth and the earth attracts every object. This is the center of the earth, isn't it? The earth attracts every object towards its center, so that the apple falls downward. It is invented by Newton. Okay, so earth attracts every object to its center of earth. Newton formulated a law based on this gravitation. That is Newton's law of gravitation. What is Newton's law of gravitation says? See, this is a chalk and this is a piece of paper. When I put this chalk and paper at the same time, which one will reach at the ground at first? Which one will reach the ground at first? Yes, you can clearly say that the chalk, because chalk has greater mass. This paper has less mass. So the chalk will reach the ground at first. So the force of gravitation depends upon mass of an object. Here the chalk reaches the ground at first because the earth attracts more chalk. Isn't it? Earth attracts more the chalk than the paper. Force of gravitation or force of attraction between this chalk and the earth is greater than the force of attraction or force of gravitation than paper and the earth. Isn't it? Okay, so why is it happen? Because the chalk has greater mass. So the force of attraction or the force of gravitation depends upon the mass of objects. So we can say that. So Newton's law of gravitation says the first point, that is force of attraction or force of gravitation is directly proportional to the product of their masses. Here, suppose when the chalk falls onto the earth, one object is the earth. When the chalk here, this is our earth and this is the chalk. When the chalk falls to the earth attracts this chalk, isn't it? So there are two objects. When there is force of attraction, there are two objects are there, isn't it? When force of attraction does not occur only in one object, it occurs only there is two objects. So the mass of two objects is given. One is capital M and other one is small m. This is mass of one object and the mass of another object in attraction. Okay, so force of attraction is directly proportional to the mass, the product of their mass. Why is it directly proportional to? That is, I already said that when mass increases, this attraction increases because paper has less mass. So it attracts this, its force of attraction with the earth is very less. Okay. Here the chalk has greater mass than the paper. So the chalk reaches the ground at first because the earth and the force of attraction between the earth and the chalk is very greater. So as the mass increases, as the mass of this object increases, this force of attraction increases. So force of attraction is directly proportional to the product of their masses. The next one is the distance. Okay, then how is the distance influence the force of attraction or force of gravitation? Do you know? That this is object A and this is object B and this is object C. Okay, these are three objects. Here I ask you a question, that is, here which one has greater force of attraction? Here which one is more attracted, AB or BC or AC? Yes, from the figure we can clearly say that object A and B has greater force of attraction. Isn't it? Because the distance from the A and B is smaller as compared to the distance between B and C and A and C. The distance between B and C is greater and the distance between A and C is greater, but the distance between A and B is very less. So the distance between A and B is less, so it has greater force of attraction. The distance between the objects B and C and A and C is greater. So there is force of attraction is very less. So the distance, as the distance increases, the force of attraction decreases. As the distance increases, the force of attraction decreases. So we can write it as F is inversely proportional to 1 by d square. That is, it is inversely proportional. Or we can say that F is directly proportional to 1 by d square, or F is inversely proportional to d square, or F is, the force of attraction is inversely proportional to the square of the distance between them. Suppose here there is two objects and the distance between and the mass of the two objects is, one is capital M and small m, and the distance between the two objects. The distance should be taken at the center of the object. The distance should be taken from the center of the object, that is this one. This is not the distance of two objects. The distance of objects should be taken from the center of these two objects. This is D. Okay, so F proportional to M into M. As mass increases, the force of gravitation or force of attraction increases. The F inversely proportional to D square. So what is Newton's law of gravitation says? The force every object attracts every other object in the universe with a force of gravitation or force of attraction, and that force is directly proportional to the product of their masses. Okay, mass of two objects, and inversely proportional to the square of the distance between them. Inversely proportional to the square of the distance between them, because as the distance increases, these two objects attraction decreases. So we can put this equation number 1 and this equation number 2. So by combining these two, equation 1 and 2, we get F proportional to M into M by D square. By combining these two equations, we will get M by D square. Okay. In order to change this proportionality constant, we have to multiply this with a constant. In order to change this proportionality constant into equal to sign, we have to multiply this with a proportionality constant. Okay, and that constant is G. That is F is equal to G m by d square. Okay, this is our equation. F is equal to Gmm by d square. So this is our equation for force of gravitation, that is Gmm by d square. What is G here? It is a proportionality constant. G is a proportionality constant. G is called universal gravitational constant. What is the value of G? G is equal to 6.67 into 10 raised to minus 11. 6.67 into 10 raised to minus 11. What is the value of G? 6.67 into 10 raised to minus 11. And there will be a unit for G. What is the unit for G? By rearranging this equation, we will get G is equal to here F into d square by m. Here d square coming to this side into multiplication F into d square all divided by here capital M and small m is multiplication. So coming to this side, it will become division. So here G is equal to F into d square by m into m. So what is the unit of F? Newton. What is the unit of d? Meter square by here mass. Mass into mass, that is kilogram into kilogram. Okay, so the unit of G is Newton meter square kilogram raised to minus 2. This is the unit of G. So value of G is 6.67 into 10 raised to minus 11 and the unit of G is Newton meter square kilogram. Newton meter square per kilogram square. Okay, hope you understand all these things. This is the Newton's law of gravitation. What is Newton's law of gravitation state? Every object in the universe attracts every other objects. And that force is directly proportional to the product of their masses and inversely proportional to the distance. Square of the distance. That is, as the mass increases, the force of attraction increases or decreases. As the mass of the object increases, the force of attraction increases. As the distance increases, as the distance increases, the force of attraction decreases. Okay. So by combining these two equations, we will get F proportional to mm by d square. Then to change this proportionality constant into equal to sign, we will multiply it with a constant that is known as universal gravitational constant. And the value of universal gravitational constant is 6.67 into 10 raised to minus 11 and the unit of gravitational constant is Newton meter square per kilogram square. Okay. Hope you understand all these things. Then we do some problems related to this equation. The first problem is in your textbook, example number 10.1. The mass of the earth is 6 into 10 raised to 24 kilogram and that of the moon is 7.4 into 10 raised to 22 kilogram. That is, mass of earth is 6 into 10 raised to 24 kilogram and the mass of moon is 7.4 into 10 raised to 22 kilogram. That is, here the two objects are, one is earth and one is moon. Here we determine the force of attraction between moon and the earth. The earth mass of earth can be taken as capital M. 6 into 10 raised to 24 kilogram. Okay, the mass of moon can be taken as small m, 4 into 10 raised to 22. 10 raised to 22 kilogram. Okay. Distance between the earth and moon, that is, here it is earth and moon, the mass of earth and moon is given, and the distance between the earth and moon is 3.84 into 10 raised to 5 kilogram, that is D is equal to 3.84 into 10 raised to 5 kilogram. This question is in your textbook, page number 134. Calculate the force exerted by the earth on the moon. We have to calculate the force exerted by the earth on the moon, that is the force of attraction. The value of G is given, that is 6.7 into 10 raised to minus 11 Newton meter square per kilogram square. Okay. So the mass given, D given, and the G, the value of G is given as 6.67 into 10 raised to minus 11. Okay. So what is the equation for finding the force of attraction? That is F is equal to Gmm by D square. Okay. The value of G is 6.67 into 10 raised to minus 11 into the mass is 6 into 10 raised to 24 into small m 7.4 into 10 raised to 22. Okay, all divided by D square, that is D is 3.84 into 10 raised to 5. All D square, so all square. Okay, so by substituting these values, we will get the answer as, by doing the calculation, we will get the answer as 2.02 into 10 raised to 20. 10 raised to 20, that is what is the force of what is the unit of force of attraction? That is Newton. Okay. So here is a question. The mass of the earth is given as, and the mass of moon is given, and the distance between the mass of and the distance between the earth and the moon is given, and the value of gravitational constant also given, and we have to find the force exerted by the earth on the moon, that is F is equal to Gmm by D square. G is the universal gravitation constant. M is taken as the mass of earth and small m is taken as the mass of moon, and the distance between these two earth and moon is D. Okay, by substituting the values, we will get the answer 2.02 into 10 raised to 20 Newton. Newton is the unit of force. Okay, hope you understand this. Then we do the next problem. How does the force of attraction between the two objects changes when the distance between them is reduced to half and mass of an object is doubled? The distance between the object is doubled and the distance between the object is tripled. Okay, and masses of both objects are doubled. These are the questions. What change occurs in the force of attraction when the distance of the object reduced to half? Okay, when the distance between the objects reduced to half. We know the equation is here. What change will occur to the value of force of attraction when the distance is reduced to half? That is, here D is changed to D by 2. Okay, then we are substituting in the place of D is D by 2. Gm by D by 2 all square, that is equal to Gm by d square by 2 square, it is 4. Isn't it? So it is can be written as denominator of denominator. What is denominator of denominator is numerator. Okay, so we can written it as 4gm by d square. Okay, we know gmm by d square is the f. So it is 4f. Here f d, when d changes to d by 2, the force, what change occur in the force of attraction? Force of attraction increased 4 times. That means the here distance decreased to half. The force of attraction increases 4 times. Okay. Then the next one is mass of one object is doubled. Here you know the attraction takes place between two objects. There are two objects here. Here the mass of one object is reduced. That is m changes to 2m. In the place of m we will write 2m. Then we will get f is equal to g. In the place of m we will write 2m m by d square. Okay, that is g 2 taken as outside, that is 2 into gmm by d square. Here gmm by d square is the f. Okay, that is 2f. Okay, so here when mass changes to when the mass is doubled, the force of attraction also get doubled. Isn't it? When the mass changes to 2m, the force of attraction changes to 2f. Then the next question is mass of both object is doubled. Here the mass of one object is doubled and the other object is also doubled. Is m, capital M become 2m and small m also become 2m. Okay, so we can write the equation as f is equal to g into, in the place of m it is 2m into, in the place of m small m it is 2m, all divided by d square is same. Okay, so it is equal to, and 2 get 2 into 2 4 into g into m by d square. What is gmm by d square? That is f, that is 4f. Here the mass of two objects is changed to 2m. That is here the mass of two objects is doubled. Then the force of attraction is increased to 4 times. Okay. Hope you understand. Today we started our chapter gravitation. At first we discussed Earth attracts all objects towards its center. And what is Newton's universal law of gravitation or Newton's law of gravitation? Every object in the universe attracts every other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Then we get the equation f is equal to gmm by d square. Here g is the gravitational constant, universal gravitational constant, and the value of g is 6.67 into 10 raised to minus 11, and the unit of g is Newton meter square per kilogram square. Okay, and hope you understand all these problems. In the next day, we will discuss about free fall and the difference between mass and weight. Okay, so we will continue in the next class. Thank you.